Welcome to a lesson on solving horizontal trajectory problems. These are a situation where we can apply motion equations in both the x and the y direction. So things to remember about any trajectory problem. One, this is only for an object that is in free fall. That means that gravity is the one and only force on it. And two, that we keep our x and our y givens totally separate. So we can run separate calculations for x and y and have separate motion equations, and one doesn't really affect the other, except that they share values for time. So let's show you what we're talking about here. We have an example problem. A ball is kicked horizontally from the roof of a 100-meter tall building at 25 meters per second. Well, when we're looking at givens, we need to ask ourselves for each one, is this an x given or a y given? So for example, 100 meters tall. Well, that is a displacement, but to be specific, it is a y displacement. It's the up and down. So my displacement in the y direction is 100 meters, and in fact, we know that the ball went down, so it was 100 meters in the negative direction, 100 meters down. We don't know what the displacement is in the x direction, so we're going to leave that blank, and in fact, that is one of the questions that we're asked for, where the ball lands. It says that the ball is kicked at 25 meters per second, but it specifies that motion is horizontal. So the ball starts off with 25 meters per second, and there's a couple things to note about that. Well, we're at the beginning of the arc, so that's a v original. And specifically, all of this 25 meters per second is in the x direction. If your motion is horizontal, then none of it is up or down. So not only do we know the v original for x, this also means we know the v original for y. We know that it's 0 meters per second. And this is an important thing to remember about all trajectories, that at the top of an arc, that the y velocity is 0, even when you have some x velocity. Okay, now it looks like we're a little short on givens because we either need 3x givens or 3y givens, and we're not quite there, except we know one more important fact here. We know that there is an acceleration downward of about 10 meters per second squared, 9.8 when we're doing labs and stuff. So we have a y acceleration of downward negative 10 meters per second squared. Now, just like with the x velocity, we can look at this and go, we have a y acceleration downward. This also means that we have no x acceleration. Acceleration comes from forces, and the thing to know about our trajectories is the only force they have is gravity. Gravity only pulls vertically. We get no horizontal. So that means my x acceleration is 0, and that any x motion is actually going to be constant velocity. And that's going to affect the way that we deal with motion equations and other stuff. Okay. We're being asked to solve for what the time in the air is. And I can see that I have 3 givens in the for my y givens. I would need more in my x to solve, but that does sometimes happen. We can solve for time using either x or y wherever we have enough information. So if we take stock there, we have dy, we have v original y, we have the y acceleration, and we have time. So the equation that has all 4 of these in it is displacement equals v original t plus at squared over 2. And I'm just putting y's when I write the equation, because this is a y calculation and I want to make sure that I'm not going to get it mixed up with my x stuff. We cannot mix and match x and y variables. I'm also going to go ahead and zero out this part of the equation because, hey, when my v original y was 0, that makes this chunk disappear. So time was our unknown. And if I want to solve for the time here, I'm going to have to multiply both sides by 2. I'm going to have to divide both sides by a, the acceleration. And then I'm going to need to take the square root. At this point, I can put in numbers. So I'll put in my 100 meters, negative, and my 10 meters per second squared, negative. Please note that we would have a real problem if they were not both negative, but they're both in the downward direction. So we need to be consistent. Everything, if I make one thing down negative, they all have to be negative. And when I type that into my calculator and take that square root, I get about 4.47 seconds. So, okay. I'll record that I have my time of 4.47 seconds. And I'm also going to copy it over into my x side because now I could use this to calculate some of my x unknowns. And in fact, my next unknown, where does the ball land? What is the x distance? So I need to find that x displacement there. dx is my next big unknown. And let's take stock of what we have. Well, I have dx. We also know the acceleration, the time, the v original. Now, the fact that the acceleration is 0 is going to cause sometimes some confusion because really there's only one equation that really ever ends up working to solve for any x variable. It ends up actually being the same motion equation that we used, but it's going to look really different because now for my x motion, with the acceleration being 0, we just get that displacement in the x direction equals velocity in the x direction times time. And this could be final or original because, hey, if there was no acceleration, the final and the original velocities are the same. And we don't want to fool ourselves into thinking that like, oh, I could solve for these. And because all I get is an equation that doesn't tell me anything new. This equation, that displacement equals velocity times time when there's 0 acceleration, that's all that we can ever actually use for our calculations when it comes to x variables. All right, so since displacement is our unknown, I will go ahead and put in my numbers there. 25 meters per second and about 4.47 seconds. And when I multiply that, I get roughly 112 meters in the x direction. All right, so we've figured out the time that it's in the air. We figured out how far it goes before hitting the ground. The last part we are asked for is the ball's speed when it lands. So, okay, that's v final. But wait. Remember how we had to ask with our givens, is that an x given or a y given? Well, the same as with our unknowns, v final. Is that v final x or v final y? And the answer is yes. We have, when the ball hits the ground, we have an x velocity of 25 meters per second, but we also know that it's moving downward. And so we're going to have to come up with the y velocity, and then we can combine these two, and we'll show how to do that. First order of business, though, I know that it's moving 25 meters per second to the side. I need to figure out how much it's moving up and down. So v final y is my unknown. And when I look up at my table, I can see that I have acceleration, I have my v original, and I have time. I'm going to point out that we could also have displacement, so we actually have plenty of equations to choose from, but the one that is the easiest uses these three givens because it's v final y equals v original y plus a t. It's already set up for us in the way that we want it. I'll go ahead and zero out that v original. So v final is going to be equal to negative 10 meters per second squared, or 10 meters per second squared down, times my 4.47 seconds. And what that's going to tell us is that v final is about negative 44.7 meters per second. In other words, 44.7 meters per second down. Okay, so wait, the ball, where is it going? Well, when it's at the bottom of its arc, it has a diagonal velocity. And that diagonal velocity can be split into 25 meters per second to the side, because that was our v final x, and our v final y, we've figured out, is our 44.7 meters per second down. And I use the negative to indicate that, but how would I get the diagonal? Well, it turns out if this looks like a familiar right triangle where I could just do a squared plus b squared equals c squared, that is exactly how we are going to solve it. This is a Pythagorean setup. A squared plus b squared equals c squared. The v final is my hypotenuse. So in other words, my v final, that is the one that's a combination of my v final x and v final y, I'm going to get by figuring out what the hypotenuse of this triangle has to be. So we'll take our 25 meters per second squared, and that negative part, when I said it didn't really matter, that's because when I square it here, that goes away. Otherwise, we end up with a negative under a square root, and we don't do any imaginary numbers. So when I put that into my calculator, solving for the hypotenuse on our triangle here, I get that should be about 51.2 meters per second. So that is the combined of the x and y speed. Okay, so big picture, things to remember. We want to remember that all of our x and y variables, we need to keep them separate. We cannot mix and match. In our equations, they're either all x variables or all y variables. Second, we want to remember that for any object that is in free fall, the x acceleration is 0 and the y acceleration is 9.8 meters per second squared down, or for our calculation purposes, negative 10 to make it easy. And finally, we just want to remember to look through our givens and keep those separate and find where we can solve for time, because then we can use that time to fill in both sides and come up with any piece of information that we're interested in. Thank you for watching, and happy physicsing.